Now, I do need to make some changes, obviously. This game is not complete yet. Notice how it says it is not this player's turn. This piece cannot be selected. Well, of course, because it's not even a piece, it's a blank space. So I need to make some changes to the messages and everything. But let me show you an example of what's possible here. Let's try the scholar's mate. So white moves king's pawn 2 spaces. Black moves king's pawn 2 spaces. And then let's say both the bishops move out. And then the queen moves here. And let's say that black does some random move like moving a pawn here to attack this bishop. But let's say the white queen goes here, and see, the white queen is protected by the bishop. So in a real chess game, the king would be checkmated in this position. It can't capture anything. However, keep in mind the game is not yet complete. The king can capture the queen. And notice something. When the king is clicked, it shows red, indicating that the king can't move on to the squares of the same color pieces as it, but it can capture this queen here because it's a white queen. But of course, this is not legal in actual regular chess, but my game doesn't behave exactly like regular chess. But this also means that the bishop can capture the king. So I guess you could say that the game is over when the king is captured. I suppose it could be that way. Instead of checkmating the king, you actually capture the king. So, for example, if you were playing an over-the-board chess game with an actual board in real life, it's possible for both players to not even notice that the king is in check. That's totally possible. So they would go on without moving the king out of check. And I feel like this game is meant to represent that. It's actually really cool that it works this way. But there are some changes that need to be made. Now I can press R and I can restart the game. I don't have a way of saving or loading the game at this time, but most things work correctly in this game. However, there's one key thing that is not right. So, for example, let's say we move queen's pawn. Black moves queen's pawn. Okay. Let's try to set up the queen's gambit. So, look at this. Now it's black's turn. Notice something. It does not show that this pawn can capture this pawn. That pawn can't capture that pawn diagonally because the pawn rules are not correct. It's possible for this pawn to capture the pawn directly in front of it, but that's not the way that a pawn moves in standard chess. See, for every other piece, it just works because the way that they move is the same way that, it just works. So, like, this queen can capture this pawn here. What? Wait a minute. Wait a minute. I think, okay, which turn is it? Okay, oh, I guess it's black's turn. I guess that's the problem. So yeah. So this is funny. So look at this. This pawn can move 2 spaces and capture the the bishop. And a pawn doesn't capture that way. So clearly the rules are not correct. I do have some work that I have to do at this chess game because it doesn't behave enough like actual chess. With all the other pieces, they're totally fine because like the knights, they can move according to the standard rules. So we can have the knights move. This knight can capture this pawn. This knight can capture this knight. It works, and the queen has the proper range of motion, so that it can move like can combine rook and bishop. So it works. It totally works here. But I still have some work to do. So let's first of all, I'm going to close the game. I'm going to reopen the game. So here's what happens. If I click on an empty space, it tells which square it is, what its name is. So like C3 or D5, it says it is not this player's turn. This piece cannot be selected for move. But it's actually not a piece. So first of all, I don't want that error message to appear unless we actually select the wrong piece. So for example, yeah, this is correct. It is not this player's turn. This piece cannot be selected for move because it's white's turn, not black's turn. And if I click on white's piece, it says this piece has been selected for possible move. And now that it's black's turn, as it says here, if I click a piece, it won't let me select that. It will show the potential places it could move, but it won't actually let me select it. It looks like it's selected, but only because of the highlights. So I have some work I need to do on this. Well, I'll leave this terminal window open because I'm going to be using that. So here's the thing. There is a main.c file, and then there are 4 header files. One is just for drawing the checkerboard. One is the font library that draws the letters, and that's almost 7 kilobytes right there, because the font rendering code is actually super complex, and it's pretty much identical to the way it was in Chaste. I copied my same font library, so arguably it works. But let's go to the main.c source file. We're just opening this up in the plain text editor. Okay, so let's look at it is not this player's turn. So here's the thing is, so this section of code here happens only if there is no piece selected. So at the start of the game, obviously there's no piece selected. I understand the way this works. I don't know if anybody would be able to understand the code. I'll explain some of it though. So the idea of the selected piece is to start with the zero of the game to signal that no pieces are currently selected. So here's what it does. It always pulls the event. So if at the very start of the game, it sets several variables. It loads the font. It has a lot of initial setup code. From the start of the main function here, all the way to here, it creates the checkerboard, initializes all the data, and then render present. And then, before the loop begins, it sets the ID of the piece selected. PS is short for piece selected, which means the piece that was clicked that is then selected. It's complicated, but so then here's the game loop, as it's called. Loop equals 1. So while the loop is not equal to 0, which is implicit in the C programming language, because anything that's not 0 is true and anything else is false. So instead of while loop is not equal to 0, just doing while loop, it works. It works absolutely. So every time it goes through this section, it's going to, if there is a mouse click, it doesn't matter which button is clicked of the mouse button, left, right, or middle, they all behave the same. It gets the it first gets that position. It gets the position of the buttons, and it took a while to figure that out. I had to read documentation. It was kind of crazy. So yeah, there we go. So then it divides it by the rectangle size, which is 90, because this 720 is the total size of the window. So 8 squares on a checkerboard divided into 720. So 720 divided by 8 squares is 90. So it's 90 pixels for each square. And that is important for other parts of the game here. So now this is interesting. So this section only happens if no piece is selected. Then it will allow selecting a piece. So here is where so notice this. So if the piece that's currently clicked, the P is the piece that was just clicked. It gets that part of the array at that index using the formula I created when you click on a certain square. But notice how it was showing the message, even if there was a blank space, it was doing that. So it's not supposed to do that unless there's an actual piece. So here's what we're actually going to do. We're going to do we're going to enclose these if conditionals in another if statement. So we're going to if if p dot ID is not equal to, yeah, okay, so, okay, so yeah, so only if the p dot ID, the piece that we've just clicked, if the ID is not equal to 0, and that's character 0. It's not number 0. I'm using actual character values. I could have done it a different way, but I'm just sticking with character values. So if it's if it's only if it's an actual piece and not a blank space, which is represented by a 0, only then um, will we be doing this. So let's see here. I'm trying to see here. Okay. Trying to make sure I do this right because I don't have syntax highlighting right here at the moment. So I'm hoping I'm doing this right. So if PID is not equal to character 0, then it will display these messages. But okay, so here's the thing. And okay, and then it will select the piece only if this conditional is true. Or it will not select it because it's not the player's turn. So now that I've added this conditional to enclose those, here's what we're going to do. Okay, so let's try. Oh, notice how now I click on a blank space. It just tells what the letter and number identifying that square is. If we try to click on a black space, it will say, you know, this piece it is not this player's turn. This piece cannot be selected for move. But then we click any of the blank spaces, it just says a blank space. Cause I've got a blank space, baby, and I'll write your name. Okay. But we can still select these pieces. So, but yeah, and we can't select it because it's not white's turn. White has already moved. So we can't really do the queen's gambit because the pawns need to be fixed. They're not supposed to capture like this. So the idea, the main goal of this stream, besides just showing off that I'm working on a chess game, is I want to actually make progress. So let me just check on how OBS is doing. Okay, I've been live for 15 minutes. So I'm going to try to fix the pawn rules within this stream if I can. And sadly, the world will never see it on YouTube. It'll only be available on Twitch or perhaps any other sites that I am able to upload it to. But my YouTube is deleted, so that's sad. So I need to do some things. So let's see here. Well, notice what it does is, so then if a piece, let's see here. Okay, so this, all right, so that was the code that I just worked on. So else, so this means, okay, yeah, so I need to indent this so it's more clear exactly what's going on here. Because the indentation is actually kind of funky here. Okay, what I'm going to do is I'm going to indent this a little bit better. I mean, it totally needs work. It would take time off stream to actually, you know, fix everything here. But yeah, it's kind of complicated that way. So, but if a piece has been selected, then so yeah, so this part, if a piece is, it is all about if it can select a piece. But if a piece is selected, this else statement will be true. So then, okay, so this one is, okay, I'm trying to see here. Okay, if PSID. Okay, I'm trying to remember how I wrote this code. So, okay, so yeah, and that's so if so yeah, if the piece ID is anything, okay, let's see here. Okay, yeah, so that's for selecting that. This is select remove previously. Okay, so so then that means if it is a blank space, let's see here. Oh, I'm trying to see here because this is if PID. Um, oh, I'm trying to remember how this worked. Okay. Oh yeah. So this was okay. So it's not this conditional, but this conditional that's for. So if the P selected ID is 0, then it's going to draw the scene. Then it's going to okay. So first it's going to get the clicked piece. So it draws the game scene and it draws the highlights of where the piece could theoretically move here. It does all that and then renders the whole scene here. And there's several different parts of it, obviously. Um, and if I remove even one part, it's going to be weird. In fact, just as a sake of example, see, if I do this, you'll see exactly what I mean. So if I do this, notice how the pieces are gone. That's because the function that I just did commented out is what draws the actual text representing. That's what it does. It's not clear by the name of it, but that's what it does. So if okay, so else okay, if the highlight equals 1. Actually, instead of having it be equal to 1, um, let's see here. Let's do if the highlight is not equal to 0 in this case. Because what if I need to have it be non-zero values of 1, 2, 3, etc. So let me just check the way the program's working right now. Let me see if it works. Yeah, okay. Yeah, it's working. Yeah, that's funny. Capturing the king with a pawn and moving it wrong. Okay, yeah, that's funny how that works. So so after it does that, then if it's that has been highlighted. So if that's been highlighted, um, okay, so yeah, if it's the color for that piece, okay, then yeah, okay. So, but if it is not, if it was not 0, there was a selected piece. Yeah, then it does that. So yeah, okay. Then, so this is if a piece has already been selected previously. So then, if the highlight is not equal to 0, the meaning that the highlighting function selected that as a possible moving space for the previously selected piece. Then we add to the move counter for the selected piece and then set that grid element equal to that piece because there's a structure for it. I've covered this in previous videos. So then it will display a message based on black or white. So white has moved, it is now black's turn, or black has moved, it is now white's turn. So it's crazy. So it changes whose turn it is. And then else it will print piece can't move there. So only in the case, so yeah, if the highlight is not equal to 0, then it will allow moving it there. But if it is that if it's an else, then that means it's equal to 0. So they will say the piece can't move there. So let's check and make sure that actually works. So let's say this king is selected, but it will say piece can't move there. That's what it will say. So that's totally cool. But the knight can move there. That's fine. All right. So clearly, though, what we have to do here is it initialize highlight it zeros. I'm gonna have to open up the other source file to show you what's happening. So we're going to initialize the highlight. It goes through every 8x8 square, x and y values of the square, all 64 squares of the chessboard. It sets that element at that index. You know the formula x plus y times width, which width is always 8 in chess, because the board is 8 squares wide. Okay, so it sets all of them to 0 through that elaborate but beautiful function. And then high loop is it's a global variable that the highlight loop control. And highlight is a function. What it does, not only does it show color coding based on whether moves are possible or not, it also sets data which lets the program still remember, oh yeah, this was highlighted as a space where that selected piece can move. And there's a lot of error checking because we have to check out of bounds. It can't allow it to check anything that's out of bounds. So that's the thing that's important. And a lot of time went into checking this. So it has comments. Okay, so like if it equals 0, that means it's a blank space. So green meaning you can go there. And if it's the same okay, so this condition happens if there is a piece and the space is not blank. Then that means if it's the same color, we can't move on to our own colored pieces. So it's going to mark it as red, meaning stop, because you can't move here and the piece is the same color as the piece you are moving. So then here what we have is, okay, so, all right, here we are. Yeah, so but then if it is not the same color, so if that square on the board, if that color is not equal to the color of the currently clicked piece, wait, p.color, wait, I'm trying to remember. Oh yeah, because this is the piece that just clicked. Okay. Then it will be marked as blue to indicate that the piece can be captured. So there's color codings, and I built in the color. It says the render draw color to that color based on the hex codes of red, green, and blue. And I use those 3 colors because they're the primary colors of light. So naturally, red, green, and blue just seem like good choices. Okay, so then what it does is it highlights the square that was clicked. It sets up a rectangle, the x, y, width, and height. And then it fills that rectangle based on those values. So it's actually a simple thing. So notice how I have a check moves rook. What it does is it calls the highlight function for it does a loop. So it does this thing where it checks. I understand in my head how it works, but to actually explain it. So like this would start out 1 square to the right of a rook if a rook was selected. So it starts out with the square just to the right, and then this starts out 1 square to the left. This starts out 1 square below, and this is 1 square above. And you have to understand the Cartesian coordinate system to really understand why it works that way, but I understand it only because I wrote the entire implementation. It's also been a while since I wrote it, so I'm a little rusty on my own program. Okay, and then this is similar, but it checks moves diagonally. Notice that it increments or decrements both the x and y values. Notice it's not just x. It's using x1 and y1 as separate temporary variables, because there is a global x and y that are used elsewhere. And I just wanted to make sure, just to be extra sure, that the variables don't conflict with each other. And then what this does here So notice that if this is for checking all legal pawn moves, as the comment says. So if the color of the clicked piece is black for B, obviously, um, then the direction is 1. So a positive direction, it's one direction, one way, and if it is um, white, then it's a negative direction because it goes upwards. So higher up is going down in Y value. So, so that's how that works. So it does chess grid highlight. What it does is it will do it'll try to chess grid highlight the square one above in the direction going 1-4 because it's keeping track because pawns move in a single direction. They have a concept of there's one way forward they move, but they can't move backwards. So pawns are special, and I have to customize the pawn rules. It's actually kind of complicated. So that's why it even works as it does. So let me just go back to the program and show you. So notice that, for example, this pawn here, it highlights these squares in front of it going in the negative Y direction. Whereas this pawn here goes downward from here, the positive Y direction. So that's just the way it works from my perspective, how I wrote the code. So it keeps track. And now notice it can move one square on the first move, I mean, 1 or 2 squares on the first move, but then only 1 square afterwards. But yeah, a new pawn that hasn't moved yet, it can move 2 squares. And I've got all of that correct. But I have to really implement things differently here. So I have to really implement, I totally have to implement the way the pawns work a little bit differently. Because in this kind of a case, I will have to do it more customized. So let's see here. So okay, so here's the way it works is that we're going to have to do something just a little bit different. So we're not going to be able to use the same highlighting function. See, the highlighting function here, it worked great for pawns. I mean, it worked great for every other pieces, but not pawns. So what we have to do here is we're going to have to do something a little bit special. Um, huh. Yeah, so that's the key is that the code is going to be different, and I don't know if I'm smart enough to write this. I hope so. But I'm going to make a separate function because see all of this stuff here is actually yeah, this is going to be a little bit different. It's going to be different here. What I may do is I may have to do things a little bit differently. We're going to make a separate function, I believe. Well, no, that won't work. Okay, yeah, so, okay, I'm going to have to customize this in a way. Hmm. Okay, yeah, I'm going to have to do this. So, okay, here's what I'm going to do. I'm going to have to make sure that, yeah, because the rules are completely different for pawns here. Hmm. Actually, though, there's another step that's actually necessary, I think. Well, actually, I'm not sure. I'm not entirely sure because, well, first of all, I think I have an idea. Oh man, yeah, this is going to be more work than I thought it was going to be. Well, no, I think I'll keep it simple. I'm going to keep all this code because it works. I'm just going to keep it because it absolutely works. So what we're going to do is we're going to do a chess grid highlight. Wait a minute. Wait a minute. I just realized. Hmm. Okay. Wait a minute. Okay. Okay. I think I have a way of doing it. We don't have to write a separate function. See, I'm thinking of this. I'm trying to be a genius and think of a clever, simplified way to write this. So here we have this entire section for pawns. So here's what we're going to do. Um, so what we're going to do here, okay, chess grid, oh, okay, I know what I'm going to have to do. Okay, I'm thinking here. Okay, here's what we're actually going to do. What we're going to do is we are going to make a copy of this function. I'm still thinking in my head how I want it. So what we're going to do here is, oh wait, oh, this is hurting my head. Okay, this is really hurting my head here. Because, oh, this is going to take me an hour to rewrite this. I can think of a way to do this. I'm just trying to think here because, see, we want it to be able to check if a piece can be captured or not. Okay, hey, I know. Okay, wait. I think I know. I'm still thinking. See, programming is hard. This is, and I'm doing this all just from my own genius brain. I may succeed or fail in this video. I don't know. This is a live stream. I don't know what's going to actually happen here. So, here's what we're actually going to do. What we're going to do here is, so it sets the direction. That part of the code is correct. Okay. So we're going to leave a comment. Okay, so set direction of pawn based on whose turn it is. Okay, yeah, that's pretty basic. That part of the code is correct. But here's what we're actually going to have to do. So, what we're actually going to do is, so if, yeah, if and only if, let's look up the formula here. Yeah, actually, yeah. Okay, okay, let me take a look back at the highlighting code here of this function. So if, okay, so yeah, so then if, okay, this is a very, very big if. Okay, if that main grid array there is, okay, yeah, if that square at that location equals 0, then this would happen. But what we're actually going to do, we're going to copy that conditional. That's what we're going to do. We're totally going to Yeah, I'm figuring this out as I go along. So if um so if yeah, so yeah, actually this is weird. So this may not work entirely how I want to. I'm going to try this. So if y uh plus dir, okay, y plus dir times 8 equals that. So this conditional, so if that space is equal to 0, only then are we going to yeah, that's what we're gonna actually do here. Only in that case then are we going to yeah, so we're gonna try that. Yeah, I'm gonna see how this works. It may not work right, so let's try something. Ooh, notice that's weird there. Okay, yeah. See, it's not working correctly. It is a blank space, but we have to make sure that our parentheses are correct here. So, so if, so it's y plus dir. We need to put the y plus direction in parentheses here. Okay, equals 8. Yeah, then it will check that spot there. Okay, so see, so that one works right for right now. And notice now, notice that it won't allow us to move onto that square, which is actually quite interesting. But actually, let's try something. So yeah, it allows moving on to yeah, there, yeah. Yeah, okay, yeah, that's actually very interesting. Okay, let me try something here. So let's say we move this pawn here and we move this one here. Notice that it will allow this pawn to capture this pawn that's 2 squares away. And we're not supposed to allow that either. So here's what we're actually going to do. So we've enclosed this. So if um, if that pawn there in that direction is a blank space, if then we're going to highlight that, and because of the way the highlighting function works, it will always highlight it green. So here's what we're going to do then. We're going to do the same thing, but we're going to okay, so if all right, so yeah, so then what we'll do is we will do an additional if statement. So then if so then this additional condition, if y plus dir times 2, okay, times 8 equals 0, then well, yeah, we're going to enclose this. Then this conditional statement's going to happen. Okay. So let's see if it works correctly. Okay, so here's what we're going to do. So yeah, that one can move there. This moves here. Notice now, see that we can move to 1 square, but we can't move 2 squares. So yeah, so now notice that it will only allow pawns to move onto blank spaces. It will not even attempt to show that as a valid move. So now pawns only move correctly based on yeah, they can move to blank spaces, but they can't move anywhere else. Meanwhile, other pieces can do all kinds of things. They can do stuff like that. Let's see. For example, let's move the knight here. This queen can capture the pawn, stuff like that. But this pawn, see, the pawn should be able to capture this queen or this pawn. So we still have to do things right here. We have to do things right. But we've added in the conditionals such that at least the pawns. Okay, yeah. So see, yeah, we at least we fixed the conditionals. Yeah. So yeah, it will only allow pawns to move forward if there's nothing there. But then we want to be able to set up captures. Okay, I've almost got it. I've almost got it, people. This is actually really impressive. Okay, so now we've got this. We've got this correct. Okay, so, okay. Um, these next two sections of conditionals make sure that pawns move forward only onto squares. Well, yeah, onto blank spaces, but can't capture pieces directly in front of them because this is not legal in chess. Okay. 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 Um, so then, but we need to add special things. So, okay. Okay, and then we'll just make another comment. End of pawn moving forward section. Okay. Okay. So then we're going to have another section where we're going to highlight. We're going to be doing this. Okay, so this is going to, yeah, and see now the pawns moving 2 squares ahead only happens if the pawn has 0 moves. And remember, every time a piece actually moves, it increments the move counter of that selected piece before it gets copied to that other element. Okay. I love the C programming language. It's so cool. Okay. So, okay. 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 Pawn capturing section. Okay. So now here's what we're going to do. We're going to do something similar to what we did. Okay, so what we're going to do is now, remember, now the rules are opposite. A pawn can't move diagonally if a space is blank, but it can move diagonally on the condition there is a pawn there, or another piece. Okay, so here's what we're going to do. We're going to copy this conditional. So we're going to do this here. So if main, yeah, dot main grid dot array. So for example, x plus 1 plus, plus y plus direction there times 8. Okay. If that is not equal to 0, then it's going to highlight. So let's try this first of all. So let's try this. So let's say queen's pawn moves here. Okay, then we got this. So now, okay, that piece can't do anything. Can't do anything there. So let's move this piece here. But now this one, yeah, it can move there. Huh. Let's see here. Yeah, I'm trying. Okay, what have I done here? Okay, so we have. Oh, that's right. We have to implement this too. Okay, so x plus 1. Okay. So here's what we're gonna do. We're going to try this. I'm doing one step at a time. Okay, so pawn, pawn, pawn. Okay, but it won't let us do anything there. But this one, see now this one works. This pawn can capture this pawn, but not the reverse. Okay, so yeah, now we're showing it. Now we're actually showing it. Okay, so here's what we're doing. So yeah, we're going to, so we've got this one. So it does diagonally forward in one direction, whichever the direction is set for that. But then we're doing this as well. Okay. So then x minus 1, and then we'll try to highlight x minus 1. So only if it's not a blank space, then it will do things. Okay, so yeah, so begin pawn capturing section, and then after all of that, then we are ending the pawn capturing section. Okay. Okay. Okay, so let's try this. So now, let's try this. Let's see if this works. Queen's pawn, queen's pawn, queen's gambit. Ooh, black can accept the queen's gambit by capturing this pawn diagonally. And this pawn, see, it can move like this, that kind of thing. But instead, what we're going to do is we're actually going to move it here. And then see, this pawn can capture here. And see, we could capture this pawn. This pawn could either capture this pawn or it can move 2 spaces. But instead, let's just move this pawn over here. And then this pawn selects this. Yeah, so yeah. You see how it works? It totally works. So let's rewind the game here. Let's start this again. So white queen pawn, black queen pawn. This time, so this pawn, it can accept the queen's gambit. It can capture that pawn. Or we can do queen's gambit declined. Okay. Okay, so the queen's gambit declined is that way. So then this pawn has the option to just move one forward here. Or it can actually capture this pawn here. In which case, this pawn can capture this one. And then now, this has worked interestingly because each side has lost a pawn. It's interesting that works, the way that works. So as you see, I actually fixed the pawn movements. And the pawns can now capture diagonally. They can capture or they could just ignore and go on. Now, it's important to note that okay, so there is a rule here that means that normally, see this this would mean, right here, this would mean that um, a pawn should be able to capture by en passant. But I don't have that really configured here. See, that's the thing, is I don't really have that configured. That's part of the problem, is that it's a little bit complicated how that is. So I would still need to do a lot more work to enable en passant. But the important thing, let's just run this program again. The most important thing about it is that because of things, we can now do the Queen's Gambit or King's Gambit. So let's try the King's Gambit just for something different. King's pawn, King's pawn. White moves this pawn next to the king here. Okay, above the bishop. And then see, in this case, so watch this. If the King's Gambit is accepted, yeah, white loses a pawn. Then white puts this knight here. In fact, it has to put this knight right here, because otherwise, as soon as black puts this queen here, if the knight wasn't here, the king wouldn't have much of a defense. The knight, of course, can capture the queen here. But let's just pretend that that knight isn't there. See, the pawn can move forward in this case. But then, of course, this pawn is there and can capture it. Then, of course, this pawn can... Well, this pawn doesn't want to capture that pawn, because, see, if this pawn takes this pawn, then queen has two options. First of all, queen could just take this pawn and put the opponent in check. But the queen could also take this rook. See, the queen has too many options here, highlighted by the blue squares. So you see, this game is a tool. My chess animate is a great tool because it lets me analyze his position. So let's say, obviously this is the best move, capturing the rook here. But let's say the king puts that. Now keep in mind, this game doesn't keep track of whether the king's in check. We know the king is in check, so the king has to move, okay? So then the queen here has the option, well, technically the queen can't put the king in check again, really. Not right now. So the king still has sort of a defense, a little bit, but not much. So the queen's probably just going to retreat here. That's probably what's going to happen. And then then of course this pawn moves out here, and of course the queen can come here and take that pawn. Fun stuff like that. But anyway, you get the idea. The point is that the King's Gambit is a complex opening with possibilities. I mean, this video has been long enough at this point, but anyway, you got the basic idea, because here I have this chess game where you can move both the black and the white pieces as long as it is the turn for that piece. So that's kind of cool. You can totally do that. Yeah, that's just fun. But yeah, so I have made, so aside from en passant and castling, everything else follows the rules of chess. Now, there are no computer opponents. There are no computer opponents in this, because if you want that, you need to download like the stock fish. I actually recommend downloading en passant, because it lets you just install chess engines to fight against from within the program. In fact, I need to install that on my Linux machine, because I have it on Windows, but I haven't installed it on Linux yet. So that's my advice if you want to play against a computer opponent. My chess game is more of a toy project that I'm just doing because I can. But I did make progress, because at least I've got the pawn capturing to work correctly. The pawns capture correctly. That's actually super cool.